Hello everyone. Before we begin, let me introduce myself briefly. My name is Tebri Zoulikha. I am a PhD student from the University of Tizi Ouzou, Latage Laboratory, Electrical Engineering Department. Glad to present my work about application of a fuzzy-based P&O in a standalone photovoltaic system in the first International Conference on Sustainable Energy and Advanced Material. Due to the nonlinearity of the voltage current characteristic in solar panel, it's difficult to determine analytically the maximum power operating voltage that varies with the change of solar irradiance and cell temperature and affected by the load condition. The MPPT is needed to surmount the troops and achieve goals, such as increase the efficiency of PV, guarantee the continuous load feeding, reduced oscillation around the MPP. For that, we present to you the outline of this presentation. We start with an introduction, system analysis and modeling, control design using fuzzy-based P&O technique, simulation results and discussion, and we finish with a conclusion. Introduction. The photovoltaic systems are more and more explored to produce clean and sustainable energy. Hence, the enhancement of the extracted and transferred electricity to load is vital to avoid any power quality problems. Accordingly, several improvements are reported to the photovoltaic systems, either on the hardware side or on the control side. In reality, the extracted power had a nonlinear behavior. Moreover, this energy is not accessible during nights and cloudy days, so controllers with power electronic interfaces are incorporated within the photovoltaic panels to feed loads. System analysis and modeling. The used system contains a PV array connected to the resistive load through a boost converter and controlled using proposed fuzzy P&O and PPT technique as given in Figure 1. The adapted panel is built a single PV cell diode configuration drawn in Figure 1 and modeled as given in Equation 1. The boost converter is interconnected between the PV panel and load. The relationship between the input voltage VPV and the DC voltage VDC is related to the duty cycle, as given in Equation 2. Phase PPT-based P&O is adopted to ensure high efficiency and quality of the extracted power. The algorithm starts by sensing the VPV and EPV, then calculating the power as given in Equation 3. The inputs of fuzzy controller are the error and the variation of this error. The output of the fuzzy is the variation of duty cycle obtained using the center of gravity. The duty cycle used to control the switching gate of boost converter. The described fuzzy controller is divided to 49 rules, such as negative big, negative medium, negative small, 0, positive small, positive medium, and positive big, as given in Table 1. Simulation results and discussion. The simulations are done using MATLAB Simulink platform. The first test is under standard conditions. As in the figure 3 and figure 4, the PV outputs current, voltage and power follow the reference value indicated in the datasheet given in table 2. The second test is given under variable condition of irradiance. The obtained results are drawn in figure 5 under variable irradiance of 0.1 kilowatt per square meter with a duration of 1 second. It's clear from the curves of both techniques that P&O shows a fast tracking speed about 0.3 seconds compared to 0.4 seconds using fuzzy logic control and PPT, when the irradiance level is less than 0.3 kilowatt per square meters. But when the irradiance level increases from 0.3 kilowatt per square meters to 1 kilowatt per meter squares, taking always a variation of 0.1 kilowatt per square meters of duration of 1 second, the power fluctuation of P&O increase and its response time decrease while the fuzzy control indicate the best performance. Then exhibit a fast tracking speed with small oscillation and total efficiency of 97.7% compared to 96.8% using P&O technique. Conclusion. A maximum power point tracking technique based on the fuzzy logic control is developed in this paper. It aims to improve the efficiency and performance of the photovoltaic system. The system is investigated in standalone mode for a DC load. The proposed algorithm is tested under standard and variable conditions. Besides, comparison to conventional P&O are done to show that the proposed fuzzy MPPT can achieve the maximum power point better than the P&O, with high performance and low loss and oscillations. However, the P&O can be adapted in low irradiance levels. Future works will be directed to the enhancement of the fuzzy control so as to adapt it to low irradiance and improve its behaviors. Apply the technique under partial shading and introduce it to large PV installation and hybrid generation using other energy resources such as fuel cell and Y. Thank you for your attention.